right? We have the equations for the conics that are centered at the origin. Right? So if we take a look at hyperbola, right, notice here we have x squared divided by a squared minus y squared divided by b squared is equal to 1. Similar to the ellipse, but whenever you're dealing with a hyperbola, you will see this minus. Notice that there are no other coefficients attached to the x or the y variable, so these conics are centered at the origin. I'm going to go back to the formula sheet and I'm going to click on this conics formula sheet, and here are the formulas for conics that are not centered at the origin. So if we take a look at the formulas for the hyperbola, notice here instead of having x squared, we have x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. Okay, so notice that h always follows x and k always follows y. So these are the documents that we're going to need for today. So we're going to start off by the definition of a hyperbola. And a hyperbola is a set of all points in a plane, the difference of whose distances from a fixed point is constant. The two fixed points are called the foci of the hyperbola. So this is what actually makes a hyperbola a hyperbola. So the curve is actually the two almost C-shape and reverse C-shapes. Okay, and this is actually one function that produces this curve, and this is a discontinuous curve. So if we were to take a point on our line, on our graph, which we have here, this point x comma y, and if we were to draw this point to one of the focus points, and then if we were to drop a perpendicular to another focus point, we can take a ruler and we can measure this distance. We take the same ruler and measure that distance. And when we subtract the two distances, we get a value. That value is the same no matter where the point is on our curve. So for example, if we were to take a point, let's say here, right, and if we were to drop a perpendicular to one of the foci points, and if we were to draw a line from the point on our curve to the other foci points, we can subtract those two distances and we would get the same number as the previous difference. Okay, so that's what makes a hyperbola a hyperbola. Okay, now this hyperbola is centered at the origin. So it says if the center is at the origin, the foci are at plus or minus c comma 0. The midpoint of the line segment is f and f prime. Okay, that's the center of our hyperbola. The vertices are at plus or minus a comma 0. The line segment in which the vertices lie is called your transverse axis. So everything happens on the transverse axis. You can find both your vertices and your foci along the transverse axis. So now we basically have two model forms. It says that the hyperbola centered at the origin, it has this equation, x squared over a squared minus y squared over b squared equals to 1. It has this vertex C and this foci, right? The vertices are located at plus or minus 0. Excuse me, the vertices are located at plus or minus a comma 0. The foci are located at plus or minus c comma 0, where c squared is equal to a squared plus b squared. Right, so notice that there is a difference. When we were dealing with the ellipse, c squared was equal to a squared minus b squared. We also had a stipulation on the ellipse that a was greater than b. Here we don't have that stipulation. Okay, A can be smaller than B. A would always come first as any one of the denominators in your hyperbola. And then we also have the second model form. Notice that in the second model form, y squared, or the y variable, is first. So we have y squared over a squared minus x squared over b squared equals to 1. And along the transverse axis, we have the vertices, which are at 0 plus or minus, well, 0 comma plus or minus a, and the foci points are located at 0 plus or minus c. To get a better idea of actually what's going on with the formulas and how the hyperbolas are situated, I'm going to use a formula sheet for the hyperbola centered at the origin. So notice on this sheet, if we take a look at that first model form, x squared over a squared minus y squared over b squared equals to 1, the curve takes the C shape in the reverse C shape form. C squared is equal to a squared plus b squared. Notice that our vertices are located at plus or minus a comma 0. Our foci are located at plus or minus c comma 0. Right? And this is how our graph is situated. We also have what are called asymptotes. And we'll talk more about asymptotes when we actually graph. But we have y is equal to b divided by a comma x, and y is equal to negative b divided by a comma x. If we look at the second model form, y squared divided by a squared minus x squared divided by b squared is equal to 1. Our curve takes the form of a U shape and an upside down U shape. Okay, c squared is always equal to a squared plus b squared when we're dealing with a hyperbola. And here are the asymptotes. Y is equal to a divided by b comma x, and y is equal to negative a divided by b comma x. And so here are the two model forms. All right, so let's take a look at the graph. So here we're asked to sketch out the hyperbola x squared divided by 25 minus y squared divided by 49. Right, so we're asked to graph x squared divided by 25 minus y squared divided by 49 is equal to 1. All right, so notice that we have the x squared variable first, and we can also determine by the equation that this hyperbola is centered at the origin. And I know it's a hyperbola because we have a difference of two terms. Right, so here we're going to graph x squared over 25 minus y squared over 49 is equal to 1. And before we graph, we're going to take a look at the model form, which is x squared over a squared minus y squared over the b squared equals 1. Where we have the vertices are located at plus or minus a comma 0. So since we're doing a sketch, we don't necessarily need the foci points to sketch, but we must know a and b. So we have a squared is equal to 25, therefore a is equal to 5. B squared is equal to 49, therefore b is equal to 7. Right, so when we write this in standard form, we have x squared over a, which is 5 squared, minus y squared over 7 squared is equal to 1. Right? So that's our standard form. Okay. So now this is how we're going to graph. So we're going to use, first we're going to plot out the vertices. So the vertices should be located at -5, 0 and 5, 0. Right. So I'm going to plot that out. So we have -5, 0, which is here along the x-axis, and we have 5, 0, which is also along the x-axis. Okay, so this is going to serve as our transverse axes. Okay. Now we're also going to take B. So we have the non-transverse points. So we're going to plot these out as 0, -7 and 0, +7. All right, so I'm simply taking B, which is 7, okay, and we're plotting out B on the non-transverse axis, which in this case is the y-axis. So we're going to plot 0, +7, which is here, and 0, -7, which is here. Now we're going to draw a box using these points. All right, so I just simply made a box of my points. And now I'm going to draw a diagonal. So a diagonal goes through one corner. It passes through the center. Okay, and out the other corner. And we're going to do the same thing here. Okay, so these are called asymptotes. And we use these asymptotes. Let me just extend these a little bit further. We use these asymptotes to draw our curve. So keep in mind that an asymptote is a line that your graph gets closer and closer and closer to, but never actually touches. Since we know our model form, right, x squared divided by a squared minus y squared divided by c squared, we should have the C and the reverse C shape. We're going to use the asymptotes to sketch our curve. All right. So this is the graph for x squared divided by 25 minus y squared divided by 49 is equal to 1. Now, in some instances, you will be asked to write out the equations for the asymptotes. Right? So the asymptote are these diagonal lines. Now, from basic algebra, you read graphs from left to right. So as we read this asymptote from left to right, it's going up, so we know that our slope is positive. As we read this graph from left to right, notice that it goes down. This will have a negative slope. So what are the equations for the asymptotes? Well, I'm going to go back to our formula sheet, and we're going to look at our model form, and it says that the asymptotes are y is equal to b over a comma x and negative b over a x. So we notice that b is 7 and a is 5. So the equation for this asymptote is y is equal to 7/5 x. And the equation for this asymptote is y is equal to negative 7/5 x. Right, so thus we have graphed x squared divided by 25 plus y squared divided by 49 is equal to 1. And we also found the asymptotes. All right, so let's take a look at some further examples. So here we're given this equation, x squared over 25 minus y squared over 4 is equal to 1. We're asked to find standard form. We're asked to find the vertices. And we're also asked to find the coordinates for the foci. Okay. So for standard form, we're given that a squared is equal to 25. So a is equal to 5. B squared is equal to 4. That means b is equal to 2. So we're going to write this in standard form as x squared divided by 5 squared minus y squared divided by 2 squared is equal to 1, right, which is standard form. We're also going to write out our vertices. So notice that the vertices are located at plus or minus a comma 0. So we have our vertices as negative 5 comma 0 and 5 comma 0. Next, we're going to pull out the foci. So the coordinates for our foci are plus or minus c comma 0. So in order to find c, we're going to use that equation. C squared is equal to a squared plus b squared. We know that a squared is 25 plus b squared, which is 4. Right, so a squared is 25, b squared is 4. So we have c squared is equal to 29. We're going to take the square root of both sides, so c is equal to the square root of 29. So our foci points are negative square root of 29 comma 0 and positive square root of 29 comma 0. Okay, let's take a look at another example. We have y squared over 9 minus x squared over 16 is equal to 1. Okay. And we're asked for the same things, the standard form, the vertices, and the foci. All right, so for standard form, let's pull out a squared, which is 9. So that means that a is equal to 3. B squared is 16. That means b is equal to 4. So writing this in standard form, we have y squared divided by 3 squared minus x squared divided by 4 squared is equal to 1. Next, we're asked to find the vertices. So our vertices are located at 0 plus or minus a. Right? And we know this by our model form. So keep in mind, in this model form, the y variable comes first, right? So we go back to our formula sheet. When that y variable comes first, right, notice that our vertices are located at 0, comma, plus or minus a. And our foci is located at 0 plus or minus c. Right? So you want to be mindful of which variable comes first. So since we have found out that a was 3, we have the vertices are located at 0, comma, negative 3 and 0, comma, positive 3. Next, we're going to determine the foci. So the foci are located at 0 plus or minus c. So in order to find c, we're going to use the formula c squared is equal to a squared plus b squared. We know that a squared is 9 and b squared is 16. So c squared is equal to 9 plus 16. 9 plus 16 is 25, and the square root of 25 is 5. So we have our foci located at 0, comma, negative 5 and 0, comma, positive 5. Okay, now we're going to take a look at some formulas that are not located at the center. So we're given y plus 3 quantity square over 25 minus x minus 2 quantity square over 49 is equal to 1. Now, since we can see that this hyperbola is not located at the center, we're going to have to use this formula sheet. Okay, so we'll talk about this in a second. But nonetheless, we're going to find the exact same things. We're going to find the standard form. We're going to find the vertices. And we're going to find the foci. All right, so first we notice that the y variable comes first in this difference. All right, so taking a look at our formula sheet, we're going to use the right half. So in the right half, as we look at our formula, the vertices have these formulas, h, comma, k plus a. So notice on our transverse axis, we have the vertices, and we also have the foci points. So the vertices are h, comma, k plus a, and h, comma, k minus a. Our foci have the points h, comma, k plus c, and h, comma, k minus c. So these are the formulas that we're going to use. All right, so first let's find standard form. So we know that a squared is 25. So a is equal to 5. B squared is 49. So b is equal to 7. So we're going to write this out as standard form as y plus 3 quantity squared over 5 squared minus x minus 2 quantity squared over 7 squared is equal to 1. For our vertices have the formula h comma k plus a and h comma k minus a. All right. So we're going to have to pull out a few things. Okay, we've already pulled out a. We're going to have to pull out h and k from our formula, right? So remember that h always follows x, k always follows y, and our signs will change. So h is going to equal to positive 2, right? Because h always follows x, and we change our sign. K is going to be negative 3 because k always follows y, and we must change our sign. So k equal to negative 3. And we previously found the value of a, which was 5. All right. So now we're just going to plug this in. So for our vertices, we have h, which is 2, comma k plus a. So we have negative 3 plus 5. And we have h comma k minus a. So h is 2, k is negative 3. And we have a minus, right, because there's a minus in our formula. And a is 5. So this gives us vertices of 2, comma 2, and 2, comma negative 8. And so again, we pulled those from our formula sheet. Now, in order to find the foci have the coordinates h comma k plus c and h comma k minus c. Right, so we're going to have to find c. Right, so c squared is equal to a squared plus b squared. So we found a squared as 25, right, and b squared is 49. So we have 25 plus 49. 25 plus 49 is 74. All right, we take the square root and we have the square root of 74. So now we have everything we need. We know that h, again, is positive 2. K, right, k is negative 3. Or maybe I should just write them out as I did before. So we have h is 2. We have k is -3, right, which we found earlier. And we have c, which is the square root of 74. All right, so now we're going to plug everything in. So the foci we're given is h, which is 2, comma, k, which is -3, plus c, and h, which again is 2, comma, k, which is -3, minus c. So here we have our foci poles. Okay. Now, before we continue with the next and last problem, you'll notice on the formula sheet for the last two hyperbolas, we don't have the formulas for the asymptotes, but I'm going to give those formulas here. So if your model form is x minus h quantity square over a square minus y minus k quantity square over b squared is equal to 1, your asymptote formula takes this form: plus or minus b over a times the quantity x minus h plus k. And if your equation is in this form, y minus k quantity square over a square minus x minus h quantity square over b squared equals to 1, your asymptote formula is plus or minus a over b x minus h plus k. All right, so these are your asymptote formulas. So let's take a look at the last example. We're given 4y squared plus 8y minus 9x squared minus 36,8 minus 68 is equal to 0. We want to write this in standard form, and then we want to find the asymptotes. And so first we're going to write in standard form. And then we're going to find the asymptotes. So to write this in standard form, we're going to have to complete the square. So in order to complete the square, remember we need a certain condition. We need the coefficient of the squared term to be 1. So I'm going to just group by like variables. So I'm going to group my y variables. 4y squared plus 8y. Since this third term is negative, I'm actually going to factor out a negative. And that's going to change my signs inside of my parentheses, right? So if I were to multiply negative times 9x squared, I get negative 9x squared. A negative times positive 36x is a negative 36x, right? So I factored out a negative. And I'm going to move 68 to the other side, so I'm going to transpose it. So negative 68, when transposed, becomes positive 68 on the opposite side. Now, before I can complete the square, I must have the coefficient of my squared term. It must be 1. So in order to force 4y squared to have a coefficient of 1, I'm going to factor out 4. So on the inside of the parenthesis, we have y squared plus 2y. For my x terms, well, since I'm going to complete the square, I'm going to put plus blank minus, and we're going to factor out a 9 for our x variable. So we have x squared plus 4x. And since we're going to complete the square, I'm going to put in a plus blank. That's equal to 68 plus blank plus blank. Right? So remember, whatever we add to one side, we must add that same quantity to the other side. So now we're going to complete the square. So when we complete the square, we take the coefficient of the middle term, we divide it in half, and we square it. Right? So 2 divided by 2 is 1. 1 squared is 1. We do the same thing with our x variable. We're going to take half of the middle coefficient of the middle term. So we're going to take 4, divide that in half, and square it. 4 divided by 2 is 2, and 2 squared is 4. Right, so we've completed the square. Now we must be mindful of what we've actually added to the left-hand side, because in order to maintain equality, we must add the same thing to the right-hand side. Right, so we take 4. 4 times y squared is 4y squared. We started with 4y squared. 4 times 2y is 8y. We started with an 8y. 4 times 1 is 4. 4 was added to the left-hand side, so we add it to the right-hand side. Right. If we take a look at the x variable, negative 9 times x squared is negative 9x squared. Right? We started with that. Negative 9 times 4x is negative 36x. Negative 9 times 4 is negative 36. We added negative 36 to the left-hand side, so we must also add a negative 36 to the right-hand side. Right, so now on the left-hand side, we have 4. Since we've completed the square, we forced a perfect square trinomial. So we have y plus 1 quantity square minus 9 times x plus 2 quantity square is equal to 36. So once we take 68 plus 4, which is 72, 72 minus 36 gives us 36. Okay, so now we're still trying to put it in standard form. So remember that our equation for the hyperbola must equal to 1. So we're going to divide everything by 36. Okay, once we reduce, we have y plus 1 quantity square over 9 minus x plus 2 quantity square over 4 is equal to 1. We have a squared is equal to 9. That means a is equal to 3. B squared is equal to 4. That means b is equal to 2. So finally, we're going to write this in standard form as y plus 1 quantity squared over 3 squared minus x plus 2 quantity squared over 2 squared is equal to 1. All right, so the next and last thing we're going to do are find the equations for the asymptotes. All right, so keep in mind the equation is based on the model form. So in the model form, we have our y variable coming first. So if we were to go back to our formulas, this is the form we're going to use. Plus or minus a over b times x minus h plus k. All right. So we have plus or minus a over b times x minus h plus k. All right. So first, let's pull out h and k. So notice that h always follows x, k always follows y. So we have h is equal to -2, k is equal to -1. We have a, which is 3, and b, which is 2. So a equal to 3 and b equal to 2. Now we're just going to substitute everything into the formula. So the asymptote formulas are y is equal to a divided by b, so that's 3/2, times x minus h, which is a -2. So I want to make sure I use a minus for my equation. I also want to make sure I substitute in h as a -2, plus k, which is a -1. So we're going to write this out as y is equal to, and that should be plus or minus, excuse me. Y is equal to plus or minus 3/2 times x plus 2 minus 1.